Hello, everyone, and thank you for joining us here today. Good afternoon, and happy St. Patrick's Day. We've got some snow and some single digits in our parades here in Northeast Ohio, as I'm sure you have some where you are as well. And I hope it doesn't dampen any festivities you have for the rest of the day. But thank you for joining us. I'm David Furbata with the Conservation Technology Information Center. We're here today to talk about nutrient stewardship strategies. And I'm here with Adam Herges of Mosaic Company. Um, you're in for a really great session today, talking about nutrient loss in U.S. production areas. Adam is one of the foremost participants in a lot of cross-sector programs and partnerships who are managing waterways around the country. And we're going to talk about both point and non-point sources, watershed-based cross-sector partnerships, new product innovation, and a lot of conservation practices that producers are using to help manage their risk for downstream pollution and waterway um, health. So before we get started today, I want to give Adam just a chance to say hello and talk a little bit about his background.
Hi, everyone. I'm Adam Herges. I work for the Mosaic Company. I've been with Mosaic now for almost 11 years. I'm our Sustainability Agronomist Advisor within our corporate public affairs team. And my main role at the company is leading and executing our nutrient stewardship strategy in North America and also supporting some of our sustainable agricultural partnerships in other countries around the world, and very excited to be here today. And I'll turn it back to David.
Thank you, Adam. Um, so this webinar is sponsored by Mosaic. It is part of their sponsorship for the Conservation in Action Tour coming up this June on the 3rd and the 4th in the Raleigh area. We're really excited about this. We have a lot of our plans underway. And at the end of this webinar, we are going to talk a little bit about the structure of that tour and give you a sneak peek into the first farm that we have confirmed just within the last week. So you're going to get the first glimpse into where we're going and what we're going to look into. And this webinar is part of a prelude of some of the topics we're going to discuss there. And nutrient stewardship is certainly important for North Carolina that gets heavy rains, that gets a lot of runoff from its agricultural fields. So this is a great way to kind of prime the pump a little bit for what we're going to see and talk about some of the other practices we're going to see there as well. Today is our last day for early registration, so don't pass up the opportunity to get our lowest rate of the season so that you can join our colleagues and really a great and diverse set of folks who attend the tour and some great farmer perspectives as well. A little bit about CTIC, the Conservation in Action Tour is our flagship event, and we really think it represents our mission to support farmer-led conservation. The tour is going to be a culmination of 10 plus perspectives from different producers. We talk about their successes and their challenges, and we've been doing this since 1982. It's important for us to understand what farmers are going through and hear their real lived perspectives so that we can understand the barriers, challenges, and successes they're having as we all work together as agriculture and sustainability professionals going forward. We are a member coalition. We are coalition driven. We are board managed, and we thank all of our members for the support they provide and the guidance they give to CTIC to help us execute on that farmer first vantage point. We also have a list of our partner organizations that are partnered in projects around the country. They help us with our research initiatives, our implementation initiatives, and help us achieve our missions and get to that field level throughout the year. So without further ado, I want to make sure we have plenty of time for Adam to talk about where we've been and where we're going with our nutrient stewardship.
Excellent. David, can you see this slide? David?
Yes.
Okay, so I'm in full screen. Well, thanks everyone for joining this afternoon's webinar with CTIC. Hope everyone learns a little bit and sort of understands the work that Mosaic's doing, but also the work that we're doing through the Conservation Technology and Information Center as well. I'm going to be talking about nutrient stewardship and strategies for continuing our long-term sustainability and productivity here in the US. A little bit about the Mosaic company. Our mission is to help the world grow the food it needs. We are the world's leading integrated producer and marketer of two very key crop nutrient products, phosphate and potash. We are a Fortune 500 company with a very rich history in mining, both potash and phosphate. And you can see here that we have over 130 plus years of experience in mining phosphate here in the US, as well as 60 plus years of mining potash in Canada. We also have facilities around the world. We're also one of the leading miners and manufacturers of crop nutrition products in Brazil. And on a global level, Mosaic, we produce roughly about 27 million tons of fertilizer products annually. And we support around 40 plus countries around the world where we sell our fertilizer products. Some of the commodity products that we produce, and folks might be aware of this, we produce MAP and DAP, as well as single superphosphate in Brazil and triple superphosphate in Brazil. And then, of course, MOP for the potash. And we do also produce feed grade phosphate ingredients for livestock. So why are fertilizers important? Well, crop nutrients are crucial for global food security. Without fertilizers, crop yields would actually decline pretty significantly. So not only are we helping to improve food security on a global level, but we're also very looking at, what are the needs of the global by 2050? And so we have a increasing global population. We need to increase agricultural production by about 70% by 2050. And folks have probably heard statistics around 50% increase in agricultural production, but it's really around 70% because as medium or low income sort of levels of the demographics start to move up into that middle class, they're going to be searching for more protein. And in order for us to increase the amount of protein on this planet, we're going to have to use row crops as livestock feed to expand livestock operations. And so, but we don't have any more land that we can expand upon from an arable land standpoint. And so we're going to have to increase crop production on existing acres that we currently have. And we're going to be doing that with fertilizer. So like I said, up to 60% of crop yields is dependent on crop nutrition. So if you think about the dinner that you're going to have around the table with your family tonight, or if you're going to go out to a restaurant, if fertilizers weren't available today, you could wipe out about half that food that's on your table. So it's critically important that we continue to leverage crop nutrition products and maximize crop yields at the field and farm gate. But there's also unintended consequences of fertilizer product use or even manure use in agriculture. And I'm going to focus strictly on the work that we do at Mosaic, which is really around how do we reduce phosphorus losses coming from agricultural landscapes. We're a fertilizer company. We produce P and K. So we're going to focus on the phosphorus issue where we sell our products. And the reason for this is really around risk mitigation. Plus, we want to make sure that future generations have clean water for their use in future years. You can see here, this is a satellite image of Lake Erie. Every year they do a forecast of the algal bloom, and this bloom, persists and presents itself every summer around Toledo, Ohio, and in Lake Erie on the Western Basin. Lower on the map, you can see a beach that is Lake Winnipeg. They also have an algal bloom that forms every year because of the shallow water, but also because of the nutrient loads coming from the Red River Basin and also the greater Lake Winnipeg Basin as well. And then on the lower right-hand side, that is actually the dead zone in the Gulf. A lot of folks don't perceive that as an algal bloom, but it actually is an algal bloom that forms. And then when those algae decay and die off and decompose, it reduces dissolved oxygen levels in that region of the Gulf. And that is why it's called the dead zone. But some of the things that we've been focusing on as well is looking at phosphorus transport and movement across the landscape. And so we kind of have this phosphorus paradox right now, specifically in the Mississippi River Basin. And so this is information that's put out by land-grant university researchers, as well as state agencies and federal agencies that are focused on water quality issues. But here in the Midwest region or the Mississippi River Basin, where 31 states drain into the Gulf through the Mississippi River, we're seeing anywhere from a pound of phosphorus loss per acre to up to 1.2 pounds of phosphorus loss per acre. However, in this region, we also have very high phosphorus use efficiency. And so there's sort of this paradox of, well, we're very efficient in our agricultural fields. Why are we still seeing phosphorus loss and water quality continue to become impaired? And we see those loads continue to increase in the Mississippi River Basin. And some of the issues for that is stream bank erosion. So within the Mississippi River Basin, there are 12 states that have nutrient loss reduction strategies that have been published and are being implemented at least over the last decade. So for 10 years, the states, 12 states and the MRB have been focused on this. However, when we look at non-point sources and contributions, majority of that is put on agriculture. And so there's been plenty of peer-reviewed studies that have been measuring this. Obviously, some of these are in very small watersheds or very small creeks or larger sort of tributaries. But only one state actually identifies a quantifiable estimate of 31% of phosphorus losses coming from stream bank erosion and integrated into their state nutrient loss reduction strategies. The other 11 states are looking at this and trying to figure out and how to integrate stream bank erosion and its contributions as a non-point source into their strategies as well. But globally, this is a pretty big issue. Water is going to move down to its lowest point, and these streams over decades change. They're not always stagnant and constant. And so we see this developing where large sections of the stream bank get eroded and fall into the stream. And then within the stream, we have this phosphorus that's resuspended in various different forms. And some of the lag times between phosphorus leaving a field in Minnesota and by the time it reaches the Gulf can be decades long, up to 80 years long. And so from a policy perspective, it makes it very difficult and challenging to see the progress that we're doing on the landscape today, and is it making an impact specifically on phosphorus loads? So that was the Mississippi River Basin. However, our good friends at EPA Office of Water have put together a really nice website looking at, well, what are the other states in the United States working on in terms of nutrient loss reduction strategies? Well, we have 30 states now that are developing or have published a state nutrient loss reduction strategy. And so while there's always been a heavy focus on water quality, particularly as you talk about agriculture in the predominantly ag states, there are other states that are focusing on this as well. And each one of these states do have a non-point source strategy, and agriculture is front and center in those strategies. So it's important for us to really lean in, to work across the aisle, work with state agencies, and really we all play a role in nutrient losses in regards to water quality. I want to talk a little bit about sort of the strategies and some of the targets that we see in some of the areas where at least Mosaic has a focus. Within the Mississippi River Basin, 2025 last year, we had interim load reduction targets of 20% reduction of nitrogen loads and phosphorus loads. And they're basing that off a baseline between 1980 and 1996. But by 2035, which is the larger target for the basin, we want to see load reductions of about 45% on nitrogen and phosphorus. And through some modeling work that the Epoxy Task Force has worked on with their partners, we want to see a dead zone below the size of about 2,000 square miles on a 5-year average. How are we looking in the Mississippi River Basin? So U.S. Geological Survey puts out this information every year or every other year. And within the data right now, we only have the load and water quality data from 2024. So 2025, I've been told, will be published here within sometime in April. And so we'll get a chance to look at that. But what's important to note here is when you think about the interim target goal for nitrogen is 20%, we actually hit that. We're actually minus 27% below the baseline. And so folks within the country will start to hear about this as EPA and the states do their report to Congress later this year. However, phosphorus, and we tend to think, nutrient loading would likely behave similarly, even though there are different, everything's moved by water, and phosphorus has a tendency to really latch on to soil. And so when we see soil loss, we see phosphorus loss as well. But phosphorus is 10% above the baseline. Last year or 2 years ago, the data showed that it was 2% above the baseline. So that's why we're sort of focusing on the dynamics of lag time and delivery, looking at legacy phosphorus as well as stream bank erosion, trying to look into the science and try to get a better understanding of what's going on, at least from the phosphorus standpoint. I want to turn to Lake Erie, which always makes the news cycles every year. And if folks are aware, this really became a hot button issue back in 2014 in August when the algal bloom pretty much moved across the lake into the water intake facilities for the city of Toledo. And mitocystin toxin, which is a toxin developed by blue-green algae, made it into the water treatment facility. And so the Toledo, about 500,000 people in the city of Toledo woke up on that Sunday morning in August of 2014 and had a no drink or no water use advisory. And that lasted for about 3 days. So picture yourself waking up on a Sunday morning wanting to have a cup of coffee or to take a shower, and you can't even use the water within your home. And that lasted for 3 days. And so, these issues happen, and we have to continue to keep our foot on the gas pedal and make sure that we are reducing nutrient loading going into these freshwater water bodies that we use for human consumption and other recreational activities. Within Lake Erie, so they've been working on reducing phosphorus losses for quite a while. So their goal for the Lake Erie Basin is, Western Lake Erie Basin is a 40% reduction of total phosphorus entering the lake. And then a more heavy emphasis on spring total runoff as well. So a 40% reduction on dissolved reactive phosphorus. And so, we've been in this region for a long time, not just Mosaic, but agricultural organizations and others. And so recently, just earlier this year, we got to know a little bit about, well, are we making any progress? And we are. And the spring total runoff of dissolved reactive phosphorus loads, we're seeing a 10% reduction over the last 10 years. And a lot of that is due to 4R nutrient stewardship, but also the efforts of H2 Ohio and the state funding that was provided. And the surge of agricultural groups working together with conservation groups as well to get practices implemented on the landscape. I also wanted to highlight North Carolina, since that's where we're going for the Conservation Action Tour this year. So North Carolina took a different approach in their nutrient loss reduction strategy. They've taken an approach of looking at watersheds where nutrient loading has been pretty significant. But they have a goal generally in the state of reducing nitrogen loads by 40% and phosphorus loads by about 77% by 2041. And they have specific strategies in the watersheds that I've identified here on the slide. So a little bit about Mosaic and our approach to nutrient stewardship. So our strategy is really to reinforce Mosaic's position as a leader in 4R nutrient stewardship. And we take sort of a three-pronged approach in terms of the resources that we have available through our grant funding and the partnerships that we want and the partners we want to work with across the landscape. And so we're really looking at, targeting where Mosaic's products are applied and used, looking at current and potential threats of regulation around fertilizer use, because we want to make sure that farmers and ag retailers have social license to operate. And we know that if we can focus on 4R nutrient stewardship as the foundation, control what we can control, we can't control Mother Nature, we can make some significant gains in making sure that those fertilizer products stay in the field and do not run off into ditches, creeks, or waterways. And then we also are focusing on areas within the country where we have existing water quality impairments, where we have harmful algal blooms already present, or watersheds where we're starting to see an uptake in phosphorus losses coming into that watershed. And through our grant funding, we work with the most impactful partners and organizations. We're focusing on those key geographies laid out by our three-pronged approach. And we're really starting with in-field practices related to responsible fertilizer use under the 4R approach. And then we know that that's not going to be enough. Scientifically, empirical data from land-grant universities that have studied this, just focusing on 4R nutrient stewardship alone will only get us about 15% reduction in nutrient losses. But we have to control that foundation. We got to control what we can control. And then we look for other sort of conservation practices, whether they're in-field by using cover crops, or edge of field practices like bioreactors, saturated buffers, buffer filters, and other sort of conservation approaches that we can try to trap and control and keep those fertilizers in the field where they are most needed as the biggest investment for farmers when they're growing a crop. So what is the 4Rs? Well, it's fairly straightforward and simple. It's utilizing the right source with the right rate at the right time and in the right place. But this is very specific to each soil type, each cropping system. And so when you're thinking about sources from a farmer perspective, or even an ag retailer, which they provide about 97% of the nutrient recommendations for farmers. Think about stabilizers, other technologies like enhancers, biologicals. Really disciplined agronomy needs to be a focus as well, looking at that balanced crop nutrition approach. And with right rates, everybody likes to talk about rates. Really try to improve nutrient use efficiency, match those rates to the crop needs, leverage satellite imagery, other sort of precision ag tools to really dial in and figure out, using the right amount of fertilizer for what that crop needs. And when I think about phosphorus loads, the two critical pieces for keeping phosphorus in the field is really around right time and right place, because phosphorus has that strong interaction with soil particles. And so really making sure that if we have to do fall application, incorporate those dry granular fertilizers. If we can move that fertilizer to spring application closer to a growing crop, that's even better. And then within placement too, whether using strip till equipment or other sort of means, really getting it down to that root zone so the plant can access it. A little bit about sort of our footprint within our nutrient stewardship approach. So we work with about 17 partner organizations through memberships, and you can see those logos here on the slide. So we work with a wide range of organizations, everywhere from scientific groups like Sarah 17 and Sustainable Phosphorus Alliance, all the way to sort of implementer agricultural organizations such as CTIC and Iowa Ag Water Alliance as well. We have 23 projects on the ground currently in North America. Those projects are with 18 different partner organizations. And on any given year, through my work, being the sole person that really drives our nutrient stewardship strategy for Mosaic, I'm engaging with over 100 different organizations along the supply chain any given year. Here is a sort of a map of our footprint, and where we invest our financial dollars, but also where we partner with folks and organizations across North America. So you can see here, we have 4R certification programs that work with ag retailers to making sure that they are abiding by the 4R nutrient stewardship standards. And then we also have partnerships in states as well. And you can see by the red dots, those are really where our active projects are located. And so we're really trying to focus in, the areas where we sell our products, but where phosphorus load and harmful algal blooms as a result of phosphorus enriching those water bodies. That's where we really want to focus. We're not going to do that. We're not going to focus on phosphorus issues for everybody. We're going to focus on what's important and valuable to Mosaic. So I've been with the company for 11 years. A lot of these partnerships we are running 9+ years now, sometimes over a decade. And so my main focus with our partners is the work that we're doing with farmers at the field level, helping them to try out new sort of 4R nutrient stewardship approaches or nutrient management approaches, or adopt and implement conservation practices. Are we actually making a difference? And so I wanted to highlight sort of 3 of the projects out of the 23 where we're actually seeing a difference happening. So we're a proud member of the Rice Stewardship Program with Ducks Unlimited and USA Rice. This partnership has been going on for almost 15 years, maybe longer. This partnership has probably the largest scale and impact out of any sort of agricultural partnership that I'm aware of. They're impacting close to 28% of the total US rice acres through this program. And what we've discovered with focusing on 4R nutrient stewardship, but also water management and other conservation approaches, we can see a reduction in sediment loads and total phosphorus loads coming from rice fields. And you can see those reductions there. They're in the mid to high 80% range. And the other thing that we focused on here, and we actually published, Ducks Unlimited worked with University of Arkansas to publish a social indicator research project, but we wanted to know, based on the work that we did with growers, bringing in cost share incentive programs, how likely are they to retain USDA NRCS programs? And far and wide, nutrient management and 4Rs rose to the top. So the farmers that were leveraging nutrient management cost share programs, looking at advancing 4R practices, 87% said they wanted to continue on the same acres that they had contracts on. And about over 50% of the farmers involved saw the benefits and wanted to expand their entire operation. Another project I wanted to talk about is Macoupin Creek Watershed. Now, this was a project with American Farmland Trust, great organization to work with in Illinois. We work with the Midwest Ag Group out of American Farmland Trust. And we came into Macoupin Creek Watershed, which is one of the top 3 phosphorus loading watersheds in the state of Illinois. They have a lot of soil erosion in that watershed, a lot of phosphorus losses. And so we sort of leaned in with local organizations, local partners. We developed a farmer-led council to help, the farmers as well as the ag retailers help to guide us in terms of what mattered to the farmers in terms of their operation, looking at profitability, but also the sustainability of their operations and how can we really focus on addressing nutrient losses. And 9 years later, we actually saw nutrient load reduction trends in the creek. And so we saw a 54% reduction in nitrate loading and a 21% reduction in phosphorus loading. The other partnership I wanted to talk about was through the Iowa Ag Water Alliance. This was the largest RCPP project that was provided to one organization. They've so far through this project, they've impacted over 4 million acres, and they have a suite of practices that they're helping farmers through cost share incentives to get implemented on the ground. But annually, we're seeing a 2.5 million pounds of nitrogen and phosphorus load reduction going to rivers and streams in Iowa through this work. So this work takes a long time. It takes a lot of investment, takes a lot of people and energy, but we can actually make this happen in agriculture. And so that's why I wanted to sort of highlight these projects to show folks that we can make a difference and we can actually improve water quality in agricultural settings. But it takes a lot of energy, people, time, and money to do it. Some of the things that I wanted to talk about too is, so through Mosaic, not only are we, manufacturing commodity fertilizer products, we also have performance products, and then a new suite of products in our portfolios under our biosciences flagship program. And so, these products are also helping to improve nutrient use efficiency. But what I've done over the last 11 years at Mosaic is really integrated for our nutrient stewardship as our approach within our commercial team and agronomy team, and how we message around responsible crop nutrition and fertilizer use. And so with our biosciences products, we're actually seeing anywhere from a 1 to 5% increase in nutrient use efficiency on farmers' existing fertilizer products and blends that they're using. And so we're really leaning into this, and there's going to be new products coming in the pipeline for Mosaic. And I think the fertilizer industry as a whole is probably going to be seeing a lot more innovation and technology than we have seen in the last 20, 30 years. Biologicals is really the next frontier for crop nutrition. It's one of the fastest growing segments in agriculture right now. In 2023, it was a $14 billion industry globally, and we're going to see that increase almost to $30 billion in the next 2 to 3 years. And what we're really focusing on with these products is really increasing nutrient use efficiency, maximizing farmers' return on fertilizer investment, and really seeing positive trends here in terms of ROI within row crops with these products. We're seeing a 3-to-1 ROI on average with most of these products that we're leveraging. And it's really around continuing to help the world grow the food it needs. How do we increase productivity on existing land? But how do we continue to drive and maximize that fertilizer investments that farmers have with some of the new technologies that we're bringing to the marketplace? And so, like I said, we've done a very good job of integrating for our nutrient stewardship. It's not just Adam on the sustainability team talking about downstream impacts. We've fully integrated into our commercial team and how we really talk about agronomy and leverage responsible use of our crop nutrition products. And I think, the future is going to be looking bright as we continue to increase productivity and reduce environmental impact from agriculture here in the United States. So with that, I want to thank everyone for joining, and I want to open it up for a question and answer period. And I know we are still on time, so David, I'll turn it to you for Q&A.
We are on time. Thank you, sir. Very interesting. Maybe I can kick things off, Adam. Talk about the length of time it takes to show change once partnerships, practices are starting. How long does it take? You talked about a 9-year program, a 20-year program. If we start tomorrow, when can we measure those changes?
So I think with nitrogen, we can see responses fairly quickly. With phosphorus, it's a little bit more challenging because when folks, apply fertilizer to the field, it binds with soil readily. But both those nutrients really move with water. And so if we can help to control water runoff, whether it's surface runoff or subsurface runoff, we can really try to eliminate those nutrient losses. But it does take a long time. American Farmland Trust actually put out a really nice report looking at watershed partnerships that actually made impact. And so the ones that were focused in a watershed for 7, 9 years, that's when you started to see the impact of the fruit of your labor, of implementing those practices. And some of the sort of lessons learned there as well is if you go into a watershed, whether it's a Huck 8, Huck 12, you really need at least 50%. If it's predominantly ag in that watershed, you need about 50% of those that agricultural acres or farmers engaged in that partnership to really make a meaningful difference. So unfortunately, it does take a lot of time, but I think, ag has really stepped up over the last 20 years, and I hope and it continues that we keep our foot on the gas pedal.
When you use those kinds of numbers about the critical mass needed to make change, are we talking about legacy loads or are we talking about new practices? Is it a combination of both?
It's a combination of both. So one of the things, at least on the phosphorus load perspective, farmers have become much more efficient over the last 40 years. We're not doing moldboard plow or some of those practices that were done in the 1920s, 1930s. However, legacy issues is a big deal. So practices that were done in the 1920s and 1930s, while they were sound science during that time, we know today with technology and advancements in our understanding of nutrient cycling, those practices aren't the best practices today. And so, what we saw, at least on the phosphorus side, is through the 1920s and 30s up until the 1970s and 80s was a lot of sort of crop nutrition products that were applied, manure, right? It's difficult to move manure from the shed. It's not economical. And so what we saw are these hot spots. And so that's the other thing that I think agriculture and even the land grant universities and organizations and partners that are working with state agencies, we got to drill into those hotspot issues and really focus on that. And so, that's where a discipline agronomy is going to come into play. That's where your nutrient recommendations are going to come into play. So in some sense, we almost have to flush the system out to get to where we need to go.
Where are we seeing some of those hot spots and those legacy loads? I imagine, the Mississippi is part of a lot of what you study. Are we looking at the loads in the banks and are we mitigating like we should?
Well, at least on stream bank erosion, I think we're starting to look, have a finer point of looking at that. Now, the mitigation strategies are completely different than what we're doing on agricultural landscapes. So that's going to take some hard discussions and conversations around resource allocation and what sort of strategies do we have to stabilize banks, and is it worth it, right? I know they're super expensive to do that work. We don't have unlimited resources here in the US. But we need to have those conversations. Because my sort of concern with all this is if we're not looking at all non-point source contributors and we don't hit our water quality targets that have been set by state agencies, federal agencies, and cooperation, what are going to be the levers that they're going to want to pull? And we have a very good case study of Chesapeake Bay of some of those levers that they've pulled. And I don't want to see that cascading across the countryside and losing our social license to operate in agriculture, because we know that there's practices that we can put down that have a positive impact on water quality. How do we accelerate and scale those practices while also meeting the farmer at eye level and having those conversations around, well, what's going to work for your operation? Not everything is going to work. All practices will work for your operation, but what will work, and can we make a meaningful improvement?
It's worth repeating. Thank you.
Yep.
Question from the audience. What do you think of biological soil testing, like the Haney test? How should we be utilizing these new tests in soil health, focus systems utilizing on cover crops, no-till, etc.?
That is a good question. And I'm just going to say I don't know a lot about those tests. The Soil Health Institute has, I think, done a good job sort of demonstrating what are those soil health metrics and what are the various physical and chemical tests that we can do. But I know the Cornell test, the Haney test gets a lot of excitement and discussions in the agricultural space. But unfortunately, the things that I look at, I think that's meaningful to growers is really soil organic matter. How do we actually improve that? And then how do we manage that over time? And we're seeing some pretty interesting work by ag retail using precision ag tools to really manage that. So manage their nitrogen that they're applying, but also figure out how to manage that soil organic matter.
Let's continue with some of the practices that we're seeing as successful on agricultural lands. Obviously, things like buffers, in addition to that, organic material that we're bolstering in some of our with some of our practices. What else is working?
Yeah, I would say the way that I approach this is, at least at the farm field, is you really have to have a good idea, do soil testing, figure out where those hotspot areas are, take a targeted conservation approach to those areas. Um, you know, I I worked on cover crops for 8 years with the Minnesota Department of Ag. I did my master's degree on cover crops, and there was a lot of excitement out of the gate. And I think, in certain situations, I think cover crops don't need to be blanketed across an entire field. I think they can be targeted to that area of the field that might be problematic. Um, I'm generalizing, at least from a phosphorus load perspective, but typically when we look at a 100-acre field, depending on the slope and the soil characteristics, only 20% of that field is the problem. The rest of the field is not. So if you're really trying to focus on reducing nutrient losses from a field, a targeted conservation approach might be best. But the great thing is we have a whole suite of different practices at our fingertips. And so I think working with that farmer, working with their ag retailer, their agronomist, really trying to figure out what's going to work best for them, and really try to dial in what are the issues in that field and then how can we address them.
Another question from the audience. If phosphorus has this long residence time, or should we conclude that farmers are using too much?
That's a good question. So I would say it's got a long resident time, at least once it sort of leaves the field. And so, we still don't quite know the lag time delivery and sort of what happens within stream. We have a fairly good idea of the different phosphorus fractions that occur. But, we're seeing it depends, there is a soil test summary that's done every 5 years, looking at soil testing from laboratories across the United States. When you look at bioavailable phosphorus, we're seeing reductions in a lot of farm fields. We're seeing mining of farm fields and soils. And so I think we got to continue to really investigate and look at that. But at least the lag times with phosphorus loads, what we do on the landscape, we may not see that environmental response for years down the road.
Of course, a lot of this nutrient loss comes with our soil we're losing. Question from the crowd is, now that NRCS has relaxed its soil loss standards that were in place 20 years ago, is Mosaic working with USDA, with NRCS, or anyone else to re-examine those standards? Should they be tightened?
Yeah, Mosaic directly, I would say no, but we are working with our agricultural partners, working across the agricultural landscape to really make sure that, the science is sound and that we're putting the best science forward. But farmers losing topsoil, it's a critical issue, um, and it takes centuries, upwards of 1,000 years to actually reform that topsoil. And so we really need to figure out how we can reduce soil loss as much as we can. So especially with the changing weather conditions and climate conditions, we're seeing high intense more frequent rainfall events, and it's really hard when you get a 12-inch rainfall to really keep that soil in place and not leave the field. And so we need to do a better job of looking at the science and making sure that farmers understand how much soil they're losing and what strategies we can do to prevent it.
Appreciate the questions we've gotten. We probably have time for just one more if you have it. And in the meantime, I want to tug on that thread a little bit, Adam, about partnerships. What do successful partnerships look like in this space? We're talking about watersheds that go across state lines and other municipal boundaries, state boundaries, and federal boundaries in some cases. What does a successful partnership look like?
So from our approach on a successful partnership, so our grant funding is really used for technical assistance. So I see this time and time again. People have great ideas. They come into a region. They have a lot of financial assistance for cost share, but what we're really lacking is that technical assistance. And so, when I think about companies like Mosaic and others that can help support organizations that can put boots on the ground, we really need more people on the ground working with these farmers, and really good expertise and technical expertise to help these farmers, because here in the US we have a lot of financial assistance, but the thing that's lacking is that technical. And so you want to find that partner that has the skill set, the ability to talk to farmers at their level, that are well organized and connected, that can bring other folks to the table to help advance some of these conservation practices. And then we need to continue to have a strong farm bill, and support NRCS in these conservation programs, because these practices are not cheap. But really, I think the success of a partnership is really honing in on that technical assistance.
Great. Thank you, Adam. We appreciate your partnership at Mosaic, for all you do for CTIC and for the tour.
Likewise, David.
Wrapping up here, want to give you what we promised is a sneak peek into what we're going to have June 3rd and 4th in Raleigh. We are really looking forward to the time there. This really is a 2 day celebration of conservation agriculture. And it begins on June 3rd with behind the scenes industry stops. This year will be at the BASF Center for Regenerative Agriculture. We're going to do a tour of Cotton Incorporated's headquarters, where you're going to learn all about milling. This is a hands-on experience. And the NC State Plant Sciences Center, which is a brand new facility, has a greenhouse on the roof. And it has what is really interesting about this place is it is a multidisciplinary academic environment where people can go from different colleges and different disciplines to support each other in the name of plant sciences. So it is really an innovative concept as well as a very cool structure with lots to do there. After that, we'll have our opening banquet. It features a sustainably sourced menu from local farmers and a keynote address. And this year's keynote address, we're really excited to have Vivian Howard. She is an author, a TV personality, and a whole lot more. She has captivated really the hearts and minds of many folks. One of the few daytime hosts to have a Peabody, a Beard Award, and a daytime Emmy. And the first woman since Julia Child to win a Peabody for cooking. So what's amazing about Vivian is she really does get on farm, understand what production looks like, what her options are for her menus, and has various farm to table concepts. Then we'll continue June 4th with our tour stops. We'll have multiple stops. We're really working hard to get a lot of data and experience from our farmer hosts into the programming. So I think you're going to see a next level presentation of where you can understand where the farmers are coming from, what data is helping drive field level decisions, and who's helping them make those decisions. And we'll end with a closing reception and our Hall of Fame induction. That first farm stop is going to be at Leggett Family Partnership, Leggett Farming Partnership. This is in Nashville, North Carolina, just south of Raleigh. And we're going to see diverse rotations and cropping systems that include soybeans, cotton, corn, tobacco, strawberries, of course, sweet potatoes. We can't go to North Carolina without seeing them. And we're also going to see a vertically integrated packing shipping operation as part of their operation. So we see the full farm to market scenario. They have a farm stand called Strawberry City. They serve 800 a day there. So really using their marketing and market access to help drive their sales. And what's great about this is the next generation's on the cusp of giving their input and taking over. And we get to see that dynamic of what that looks like, how that influences the decisions they're making today for the future farming generations. And a really interesting dynamic that is involved with the commodity orgs and a lot of other support groups throughout the state as well. So that's all for us today. I want to thank again Mosaic for being the sponsors of this webinar and their continuous support of the Conservation in Action Tour and CTIC. Thank you, Adam, for being our presenter today and giving us a glimpse into where we've been and where we need to go. Please feel free to see more about CTIC at ctic.org. All of you will receive a recorded version of this that you can play on demand and share with your network. Thanks again for joining us, and have a great St. Paddy's Day.